2.3 is talks about differentiation formulas. Shortcuts, you guys. You're going to be very impressed. Power rule. If n is a real number, then if you take a derivative of any variable raised to a real number, you bring the power down and you subtract 1 from the power. Did you see in the previous section we did x cubed? Do you remember x cubed? Do you remember this work right here? That one right there? You want to see how that's done? Take a derivative, bring the power down, subtract 1 from the power. Look at that work, and look at that work. Do you remember this problem? You see that lovely problem? Isn't that x raised to a power? The answer was 2 over 3 cube root of x. Well, if I take a derivative of this, that is a real number, bring the power down, subtract 1 from the power. 2/3 minus 1 is negative 1/3. Isn't that 2 over 3 cube root of x? Do you remember how much work we did? See all of that? How do you separate between this and the previous section? If I say find the derivative by using the definition, it has to be the limit. Now, if I take a derivative of a constant, you guys, a couple of ways of showing how that works. Derivative of a constant, if I take f prime, that's the limit as h approaches 0, f of x plus h minus f of x over h. Limit as h approaches 0. Well, f of x plus h is c. F of x is c. That is the limit as h approaches 0 of 0 over h, which is 0. And the limit of a constant is a constant. Or an easier way, if you look at a horizontal line, right? If you look at a horizontal line, because that's what this is. Oops. Y equals c. What's the slope of any horizontal line? It's a 0, something to remember. And the derivative of x, you could apply this rule if you want. You can say the derivative of x, well, bring the power down, subtract 1 from the power. That's really 1. If it's a linear equation, the slope of the tangent is the slope of the line. So when I say here, what is f prime? Since that's a constant, automatically a 0. So the shortcut, the power rule is going to help you with a lot of different types of problems you're going to come across. If both f and g are differentiable and c is a constant, then if you take a derivative and there's a constant, drag the constant up front and take a derivative of the function and multiply the result. If you're taking a derivative of two functions being added, take the derivative of each and add the result. Same thing with subtracting. Multiplying and dividing is a different story. So differentiate the function. If I take a derivative, well, bring the power down, subtract 1 from the power, ignore the 2. What's the derivative of x cubed? Bring the power down, subtract 1 from the power. So that is 4x cubed minus 6x squared. And you'll notice a lot of functions in this section, they didn't give you with a limit because the work is intense. This is a shortcut. Do you ever have to use the limit? If the problem says find the derivative by using the definition, that's using the limit. Would I ask for that? Absolutely. How about here? F prime equal, the 2/3 you ignore. Bring the power down, subtract 1 from the power. The negative 5, well, you can think of this as negative 5x. Negative 5, you ignore the derivative of x is 1 and a 0. And do you notice you're multiplying those every time? So that's 2x squared, and you multiply those minus 5x. So it turns out the slope of a linear equation is right there. We know that already. We don't calculate for that. How about g prime? 4 times 1.2 is 4.8, because you're going to multiply it after. 2 times 3.5 5 is 7x, and derivative of a constant is 0. If it was a rational function, guess what? That rule works as well. C is a constant. Any variable other than the independent will count as a constant. Subtract 1 from the power. The rule of thumb is, if you're given a problem with a negative power, you could leave your answer with a negative power. But you know, they could have told you this is c over z cubed. That would have been hectic to use the limit on. How about here? F prime is negative 10x to the fourth plus 2 divides 4 2 times 5, that's a 10. 5 halves minus 1 is 3 halves. I don't need to tell you how complex this would be. And here, you're going to start writing those as power functions. Now when you take a derivative, you bring the power down. Bring the power down, subtract 1 from the power. So you're going to say f prime is radical 2 over 2 radical x, minus 3 over x squared. That's simple. Here, I'm going to use my technique in algebra and write this as two power functions okay. I'm seeing things. And here, wouldn't this cancel 2 of those? And if I say what's k prime, wouldn't you say negative t to the negative 3 plus 2/3 t? And what would be my final answer? K prime would equal K prime would equal, bring the power down, the negative 2 and 1/2 cancel out, subtract 1 from the power, bring the power down, there it is. Now, we have 2 rules we have to get used to. Those are not going away. There's the product rule. Product rule is fairly simple. If f and g are both differentiable, if I want to take the derivative of 2 functions multiplied, then I would take a derivative of one of them multiplied by the second, and then I will rotate. I'll take the derivative of the one that I didn't multiplied by the second, in any order you want, because they're positive, it doesn't matter. So that's the rule for multiplying. Of course, you could multiply first, you could FOIL or distribute, but where we're going, you really need to get this out of the way. If you take a derivative, it's going to be derivative of the first times the second plus the first times derivative of the second. What's the derivative of that? That is 3t squared plus 5. No need to clean that up. That's good enough. And the same deal here. If I want to take a derivative of h, derivative of the first is 2x plus 1 times the second plus the first something I want to give you as a note, plus the first times derivative of the second. That is negative 3x to the negative 4 minus x to the negative 1. Now, a note. We take a derivative of a square root a lot more than we like. You write square root as x to the 1/2. When you take a derivative, you bring the power down, subtract 1 from the power. It turns out it's very efficient to memorize that if y equal radical x, then when you take a derivative, you could always derive it. It's 1 over twice the square root, and only square root of x. That's all we care about. The only reason we're memorizing this because it comes up a lot more than you like. It's roughly 25% of the time you see this. Now, we have another rule, and this one is a bit messier. If I'm taking a derivative of two functions divided, notice the order. I take a derivative of the top first, times the bottom. I take a derivative of the bottom times the top, but the minus must be in front of the derivative of the denominator, all over the denominator squared. So that's what you have to remember. If I want to take a derivative of this function, derivative will be, derivative of the top is a 1 times the denominator, minus the top times derivative of the denominator all over the denominator squared. On a test, this is all I want for now. If you clean it up, that is x plus 2 minus x over x plus 2 squared. The derivative would be 2 over x plus 2 squared. Until you learn about the chain rule, this is the only way of doing such problems. If I want to take a derivative of this, well, the same deal. Y prime would be derivative of the top is 2x times the denominator minus the top times derivative of the denominator, that's a 3, all over the denominator squared. On a test, this is all I want. For the homework, you gotta clean it up. 6x squared plus 10x minus 3x squared minus 3 and y prime would be 3x squared plus 10x minus 3 over 3x plus 5 squared. If I get to part E, the same deal happens. We have a space. Part D, well, y prime is derivative of the top, again, it's worth memorizing, times the denominator, minus the top times derivative of the denominator, all over the denominator squared. That's a good enough answer. Let's get rid of that, and let's give them some spaces. Push that. Alright. And y prime would be, this is a complex fraction, in case you didn't see it yet. Let me write it out slightly different. It's x minus 1 over twice radical x minus radical x over 1 over x minus 1 squared over 1. The LCD for the top and the bottom combined is 2 radical x. Multiply each of those, and this is something that comes up a lot more than you like. So if you ignore the denominators completely, that will be x minus 1 minus radical x times 2x is minus 2x over x minus 1 squared. Y prime would be negative x minus 1 over x minus 1 squared. Or you could, if you wish, factor a minus out of it and say that's x plus 1. Most likely that's what they'll do in the book. You don't have to. Those are saying the same thing. I'm going to stop here for this video and continue on with the next video.